All right, so today we're doing 10.3, which is adding and subtracting rational expressions. We are going to skip over the warm-up just because we'll probably come back to that as if you'd like to do it, obviously you can, but we're going to come back to that as part of kind of our review for the test here. I'd like to get right into our topic of the day, which is that adding and subtracting. Oh, Jocelyn, if you're looking for it, it's right here on the center table. So what we're doing, right, is we're adding and subtracting fractions. Yep. So in order to add and subtract fractions, we have to remember how to add and subtract fractions. So can anybody tell me what we need to be able to add and subtract fractions? A common denominator. So knowing that we need a common denominator, what if I want to add these two fractions? What is my common denominator? 12, right? It's called a least common multiple. We figure out what bigger number is divisible by both 4 and 3. And when we do that, the mathematical approach to do that, right, we multiply this fraction by the number 1 and this fraction by the number 1 in a way that gives us that common denominator. Once I've done that, right, I've written equivalent fractions, how do I add fractions? I'm sorry, what? Just add the numerators, right? Add your numerator, keep your denominator. That exact same approach is what we're doing today, but we're going to do it on a very advanced level, right? Because I know we're in Algebra 2. There's a bit of hemming and hawing last class, but it's all right. We're going to get through it. So say I have common denominators to start out, right? This is really nice. I don't have to worry about anything. I add my numerators, keep my denominator, and unlike when we were multiplying and dividing where we would simplify before, we wait to simplify until the end, right? 10 and 4 are both divisible by 2, so I get 5 over 2x, right? I wait to simplify into the end because you want those bigger fractions, right? Here, I don't simplify these before I add. I made them bigger so that I could add them together. So that is always what you want to keep in the back of your mind as you're doing this. For example 2, same exact thing. I already have common denominators, so I keep that denominator, and then I add my numerators, or in this case, I subtract my numerators. I get 2x minus 5 over x plus 6. I cannot simplify anything, right? If I did, the cat would die, so that is my final answer. So here's kind of right my outline of my recommendation of how you should go ahead and do this. Factor your denominators. Find the least common denominator. Sometimes that's the hardest thing, is to figure out what is the least common denominator. Multiply each fraction to get that common denominator in there. Add them up, and then finally at the very end, simplify if you can. So we're going to go through 3 examples where we just try to find the least common denominator. Meaning, like for letter A, imagine these are the denominators of my fraction. And I'm just trying to figure out what is the least common denominator between them. Well, I want to factor and see what I'm working with here. So let's factor letter A. The first thing I do is I take out my GCF, which is a 4. And I'm left with x squared minus 4. I then factor that down. So that first fraction, or that first denominator, right, is completely factored. Let's look at our next one. I have a GCF here as well of a 6, so I'm going to take that out. And then I'm going to go ahead and factor that down. So I need 2 numbers that multiply to give me 4, add to give me negative 4. All right, we've factored these down. Now let's identify what the least common denominator would be. Let's first look at the 4 and 6. What's the least common multiple for 4 and 6? Sorry, what, Tim? 12, exactly, right? We're thinking of a bigger number that is both divisible by 4 and 6. So I have to put a 12 in my least common denominator. This fraction here, this first one, says you need an x plus 2 in your denominator. All right, I better add it in. It also says you need an x minus 1. Okay, let's add that in. Sorry, x minus 2. I need to add that in. So I now have this whole thing in my least common denominator, and I haven't even checked this other one. This guy over here says you need an x minus 2. I've got one, but I don't have 2 of them. So I need to add a second x minus 2 to my least common denominator. I now have I have made sure to represent every single fraction in my least common denominator. And that's big, right? That's a big one. If you want to rewrite this here, right, as the quantity x minus 2 squared, go right ahead. Questions on how we got that? Because just sometimes finding the least common denominator is the hardest part of this whole thing. All right, let's look at letter B. So I'm going to take the 8x minus 6 and factor it. Get 8 times x minus 2. This second one, I can factor out the 12. And then from there, I'll factor it down. So I need two numbers that multiply to give me a negative 6, but add to give me a positive 1. X plus 3 and x minus 2. So let's set up our least common denominator. What is the least common multiple of 8 and 12? 24, right? 24 is the smallest, bigger number that is divisible by both 8 and 12. This one here says you better have an x minus 2. All right, let's add it in. This guy over here says you better have an x plus 3. I don't. Better add it in. And then he also says you better have an x minus 2. Oh, I already do. You're covered. I don't need another x minus 2. I already have one that I've identified in my least common denominator. Questions there? Go ahead, try C on your own. Factor it down. See what you need represented in your least common denominator. All right, your least common denominator. This guy says you need 2x plus 2's. It okay if I write it like that? We're going to want to shortcut things as much as we can as we go through today. This one says you need to have at least one x plus 2, right? You need one x plus 2. I've already got that covered. I don't want to add a third one. But I do need to add an x minus 2. So that is my least common denominator. So that kind of concludes finding the least common denominator. We're going to do 5 problems. Yep, we're only doing 5 today. It'll probably take us 25 to 30 minutes to do. I know, deep breath. Your homework today does not have 21 questions on it, okay? Thank goodness. So let's look at our first example here. I definitely don't have common denominators. The first thing I do is, it's almost like you need to start using your mathematical intuition. I'm going to factor this one out first, right? Because there's not a ton I can do with this one, but I need to see what it's made up of. But I need to see what it's made up of in relation to this one. So I'm going to factor this out. 3x is common to both. So it factors as 3x times the quantity x plus 1. You with me, Natalie? Okay. Now this one, how can I rewrite 9x squared to see what's common already with this one? 9x minus x. A different way. I could make this 9x times x. Or, how about 3x times 3x? Right? They mean the same thing. And at least I see here, it is now, right, relative to this. I can see things that are already common that exist between the two of them. So that's what I want to think about as I start to form my common denominator. So I need two 3x's, right? This guy says you need two 3x's. So I will write it as 9x squared. But I did that to show that we already have coverage then for this 3x. I don't want to put another 3x in there. It's already in there. It's buried in the 9x squared. But I do need the x plus 1. Questions? And also, if you would rather write this, right, like this, so you can kind of see it, fine by me. Does not matter. They mean the same thing. So let's actually start figuring out how we add these things together. This denominator, what's it missing? It doesn't have the x plus 1. So I need to add it. And I can't just add it wherever I want, right? I need to add it in both my numerator and my denominator, right? I'm allowed to multiply by the number 1. It's a really weird looking one. It's x plus 1 over x plus 1. But I have not broken the rules of algebra because I just multiplied by the number 1. What's this one missing? It's missing another 3x. It only has one 3x in there, so I need to add another 3x. That's the big leap. Questions before we go ahead and start adding these and figuring that out? Okay. So you know why you guys asked, like, do we have to FOIL stuff through? Now we have to, right? We have to multiply through because I don't know what I'm working with. I don't know what's common that I can add together, or if I can. So you don't have to write this step out. I should probably not put that equal sign there. Makes it look like it's equal to that. So I have 7x plus 7 in this numerator. And if you start shortcutting this, that's fine, right? I'm not expecting you to show all the work. I kind of just want to make sure I show it for our notes, that we see it. So I've distributed that 7 through. Now I go ahead and add my numerators. And I like to put the 3x squared, just in case I have to factor it. And I keep my denominators. Now the last piece, because you're like, what, there's more? Can I factor this down? Can I reverse FOIL this in any way? We will do an example where we can, but in this case, this is as factored as it gets. I cannot go any further than this. This is your final answer. Everybody doing okay? One down, 4 to go. Look at our next example. Oh, subtraction. All right, let's bring it back to, I don't know, when we learned integers. 6th grade, 7th grade? Do these mean the same thing? rather work with an addition problem than a subtraction problem, especially when it looks like this. Now you have two options when we're dealing with fractions. Say I have -1/4. I can either attach the negative to the numerator or to the denominator. Which would you rather attach this negative to? Your numerator or your denominator? The numerator, right? I don't want to deal with a -x². So what we're going to do is we're going to change this to an addition problem and put a negative sign into my numerator. Which means I will have to distribute, right? I'll take the time to write this all out. I'm going to distribute this through. So that is really the problem that I'm working with, right? But one little forgetful, I forgot to handle the negative. I recommend handling the negative right away if you have to. Now let's start to factor this, right? Let's see what factors I'm working with so I can start to figure out what my least common denominator is. This first example, I have 2 times x minus 1. This one over here, that factors x minus 3, x minus 1. So what's my least common denominator? I need a 2. I need a x minus 1. And I need a x minus 3. So that is my least common denominator. I look at my first fraction. It's missing the x minus 3. So it's missing an x minus 3. So I need to go ahead and add it in. So I have x plus 2 times x minus 3 over, and I'm going to keep it all nicely factored out. This guy over here, he's only missing the 2. That's nice. I now, though, have common denominators. I would like to be able to go through and add them, but first, let's FOIL. Right, let's FOIL this out. This numerator I have up here, and let's distribute this 2 down here. X squared minus x. We'll go ahead, keep adding. Right now I'm going to go ahead and add across. Add my numerators. So x squared, can't really be added with anything. Negative x plus 4x plus 3x. Negative 6 plus 2 minus 4 over my big denominator. Last example, we were done. This example, I can factor my numerator. I get x plus 4, x minus 1. My x minus 1's cancel out. And my final answer is x plus 4 over 2 times x minus 3. Cannot cancel anything else or a kitten would be harmed. We're done. Biggest example of the day, I think. That makes you feel any better? Why don't you guys try C on your own? Or no? Is that a no? Okay, we'll do it together. Does everybody have that one down? Okay, let's go ahead and factor, right? Let's factor our numerator here. It's x plus 2 times x plus 2. This one over here, x plus 2, x minus 2. Let's make this an addition problem and put that negative attached to my 6 up top. So we're still not violating the rules, right, of algebra. So my least common denominator should look pretty similar to the one you guys found previously in that other letter C. So it's the quantity x plus 2 squared and also an x minus 2. I'm trying to make sure I go slowly, but if I'm going too fast, please stop me. Or if you have questions, please stop me. All right, this first fraction here is missing an x minus 2. So that must be what I multiply by. So I have x plus 1 and x minus 2. Yep. Okay. This next one only has one x plus 2, so I've got to add another x plus 2. You have to, it's really about staying organized, right, and keeping track of what step you're on and methodically going through it. Now before we add them, let's FOIL the first fraction's numerator and distribute the negative 6 here. So I have x squared minus 2x plus 1x minus x plus negative 6x minus 12 Now we'll add our numerators and keep our denominators. And I'll tell you right now, this does not simplify down. There are no two numbers that multiply to give me negative 14 and add to give me negative 7. So that is as simplified as it gets. You're really loving this. Go ahead and take a look at that next page. See what we're in for.
What's
I will say, Sarah, this is really just heavy algebra, too. Right? This is testing your algebraic skills a lot. And there's a reason why these don't show up as frequently on the ACT, right? There's no way most people can do these types of questions, especially something like this, in 60 seconds. So that's why when it comes to rational functions, they're going to ask you about x-intercepts, y-intercepts, asymptotes, maybe simplifying, right, what we did at the beginning of last class, but they really can't ask too much of you. It's hard to do these problems in 60 seconds or less. All right, I know. We look at this and we get overwhelmed. Let's just take, where is there addition or subtraction going on? Yep, sorry, Alyssa. Yes, let's just figure out what we have in the denominator, right? That's the only place where we're doing addition. So we have to get a common denominator there and see what we're working with. So this fraction here has an x plus 4. Remember, those are stuck together. So my least common denominator for this denominator is going to be x times x plus 4. Right? I need to have both of those denominators represented. So that first fraction there, that's missing the x part. So I've got to add that in. Do you have questions?
No.
Okay. So I add that in, right? I add it by multiplying by 1. I need to make sure I put it in both my numerator and my denominator. My next fraction is missing the x plus 4. So I've got to add that in. Now here, right, in my numerator, I've got a 2x plus 8. It's going to do that distribution, so I don't have to rewrite the whole thing down. I then add my numerators, x plus 2x. Yes? X plus 2x. 3x, this is usually where it's really easy to make an arithmetic mistake, right? You're doing all this work, and then you just forget to add that extra x over x times x plus 4. Okay. So now at least we kind of know what fraction we're working with. And like I said, you can start to cut corners, but I am going to write this whole thing out, especially to make sure we have it correct in our notes. So my first fraction here is 5 divided by x plus 4. I am dividing that fraction by what I just figured out is in my denominator. 3x plus 8 over x times x plus 4. Now I have a problem that we did just last class, right? I can change this from a division problem into a multiplication problem. I keep my first fraction, change to multiply, get the reciprocal, and then I see if there's anything I can cancel. Anything? Those x plus 4s, right? Multiply your numerators, multiply your denominators, final answer.
What kind of math are you doing today?
Rational functions.
Oh, that's good stuff. Oh, you guys don't agree.
Look at the excitement on their
Yeah, I was
faces.
saying. Yeah, I see lots of smiles right now. Lots of excitement. Hey, these are good things, though.
You guys want to try the next one on your own?
Sure.
This is the last class. Oh, man, you guys can do it.
All right, last one for the day, okay? Open those eyes.
Hey, I believe in you guys, okay? That should be enough right there. That should get you through this problem.
Mr. Apostle wore that shirt specifically so that you would get really excited,
It's true.
right?
It's true.
Impressed by that shirt.
There's nothing you can do at the, when you look at the shirt beside you, go like, eyes wide open, and get pretty happy. I'm just saying. So, this is for you guys, okay?
We're both wearing flower shirts.
We are. We are. Yeah.
Love the coordination. Lasso shirt?
Yes. Yes. And jeans?
Yeah.
Perfect. We're on a good plan. Okay. Yeah, we're good. See you guys.
All right, let's look at, same exact approach from last one, right? We've got this in our denominator. So I need to identify what's going to be our least common denominator down here. X minus 3 and x plus 5. So I'm going to add those two fractions in my denominator. That first fraction is missing the x plus 5. That second fraction is missing the x minus 3. Distribute this out. I have 2x plus 10. I'm going to add my numerators. So 2x plus another x, 3x, 10 minus 3. And I'm left with 3x plus I know the fraction I'm working with, so I'm gonna go back to our original equation. I know, we kind of forgot, we haven't even done this part yet. So I've got to take that first fraction, 3 over x plus 5, divided by 3x plus 7 over x minus 3, x plus 5. Let's rewrite this as a multiplication problem. Cancel out those x plus 5s diagonally. And if you want, you can distribute it, or you can just leave it in that factored form in your numerator. And I wind up with 3 times the quantity x minus 3 over 3x plus 7. Unless you guys really want to do that last example. Right? We did 3 of one, 2 of the other. I agree. Your homework has 12 questions on it. The last 2 are complex fractions like this. You can do it